Because what?
You add the 5 with the
Okay, that's a 1. But it's not 5 plus 21, it's 5 plus 2 times 1. Why am I interested in this being a 1? Good, Zach. Our cosine is when it's at the highest point. That's high tide at 1. Okay, that's the shortcut here. If that is a 1 of our cosine, then our answer is going to be a height of 7. Excellent. Okay, so now we're going to find out when the t, we're going to find the t when the h is 7. Okay, is everyone still with me? Okay, now what we're going to do here, we're just going to focus on this because that graph tells us when it's high tide or low tide, okay? And what are we going to make this equal to if we're only interested in the high tide? 1. Okay. What's our goal now with this question here? In words, what, tell yourself or tell me, what do you need to do with this? What do we, got to inverse the costs, okay? We're trying to get to t, thank you, t. We're trying to get to that, okay? When you get your inverse, you want to start putting this up here. Okay. Does anyone know? You can even put this in your calculator. Cosine of 1, what does that equal to? What angle? It's 0 degrees. There's more. Okay. What else can we do? So remember, cosine means the x-coordinate, and the x-coordinate is equal to a 1. And on this circular, where is it? It's right here, at 1, 0. Gabe said 0 as our angle or radian, degree, works. But what else works? A 2 pi. What else works? A 4 pi. So we just keep going. You could go on forever. Okay. Good pattern is just to do maybe 3 or 4. And if we need more, we'll do more. I want to get t by itself. What am I going to do if I have it divided by 6 on the other side? Times them all by 6. Oops. And if I've got a pi attached, what do I need to do on the other side? Divided by pi. I'm just going to do the long way so you know it's all the way here. Etc. So now we have 0, 12, and 24. Okay. This question here is the first 24 hours. We've already reached 24 hours. Okay. What time is 0? 12. 12 what? 12 a.m. This is? PM. And this is? 12 a.m. again. Okay, that's what's happening here. Let's go next question. Okay, Think about it. What is the difference in height between the high and the low tide? We know what's high tide.
Honestly,
So
when it equals 1.
when it equals,
Half that.
okay. What type of one?
Neg-
-1. We have a wave going, cosine, low tide. We're interested at height equals -1. So when I go over here, who knows what the height of the low tide is? Anyone got a? I'm just going to change this to low tide. We're not interested in 1 anymore. We're interested in -1. And what's my height of the low tide? If you put all the numbers together, it's 3. Very good. Okay. 5 take away 2 is 3. Okay. What's the difference? The question is asking, what's the difference? 4. It's 4, because 7 take away 3 is 4. High minus low is a 4. Any questions? Almost there. 2 more questions to go. You are going to now, I'm going to give you some time on a scrap piece of paper to draw the graph.
Okay.
Have a go. Draw the graph. Who needs paper? Just pull it. Perfect paper. Who else needs a scrap piece of paper? Let me get some. This is just rough. Just sketch it. I want to see what you do. Okay, give you some clues as well. What's the equation for period? 2 pi n. You got to make sure your n is correct when you read it off. Get your n together. What's the period? What's the n? There's an n in here. What is it?
Oh, wait, no. 1/6.
It's not 1/6. He's got a period for me. It is 12. Okay.
I want you to graph here.
Because my n is in front of the variable. Good, Nathan. So remember, you can do it this way just to make it clear for you. Then reciprocate. You get your 12. Pi's cancel. What does period mean again? In your own words?
Like 1.
One wave. So one cosine wave is just 12. So how many waves do we need? We need 2. Why? Why are we after 2? Because this question is about 24 hours. We need 2 sets of 12. That's your next clue. Two waves, 12 and 12 of a cosine graph. But remember, the two, what does the two do? What does the two do? Amplitude. And what is amplitude?
What?
It's the height. So we're not working with ones and negative ones as we did before. We're working with twos and negative twos. And there's one more thing you need to do. And what is it? The shift. Are we going up, down, left, right? Going up. Just because it's at the front doesn't mean anything special. Whole graph is going to go up by 5.
So it's like we said it's 7 at grade. Yeah.
Okay. I'm going to start sketching my graph. Hopefully it matches up with yours.
It's not 6 cents.
So why you got a 2 and a 4?
Just say I just made it even, so I'm just making it. I'm just counting up.
Yeah.
Who's finished? Anyone? Okay. Okay, so high tide at 7, low tide at 3. We're only working between those two, and we're doing a cosine wave in between there. Oops. Okay, that's our first wave, and we do it again. Remember, it's just a sketch. Although I've got a grid to help me, it's just a sketch. Okay. Any questions with that? Now, let's move on. I'm going to read this question out. You're going to have to hear it because I don't want to give the answer away. John North knows that his trawler needs a depth of at least 6 meters to enter the harbour. Between what hours is he able to bring his boat back? I'll read that again. John North knows that his trawler needs a depth of at least 6 meters to enter the harbour. Between what hours is he able to bring his boat back? You need to do something to your graph right now to use the clue that's been given in D. Do something to your graph. The clue is 6. What are you going to do to your graph with the clue of 6 to help you visualize that? Okay. What are you going to do to your graph? Who's added something to the graph? Okay. Maya, what did you do? A line at y equals 6. Did you do that, Gabe? Emily?
Yeah.
Okay. So that's what we're interested in, is 6 meters. Because that's height. And height is simply depth. The same thing. That's what we're interested in right now. The question. Now you can see the question. Is this. John North. Oh no, not that one. John North knows that his trawler needs a depth of height at least 6 meters. We're not done yet. Between what hours is he able to bring his boat back? Between what hours is he able to bring his boat back? In another pen or pencil, can you color the lines that you're interested in on your graph? Can you color? Or you can make a squiggly line, something to say it's different. Okay, what are you interested in this question here? Between what hours is he able to bring his boat back? If we've got 6 up here, which sections of your line are you going to color in to highlight what you're trying to work out? So I'll give you a moment. Who's done some coloring in? Who's colored in? Okay. Did people do that? Okay, that's what we're interested in. Now, we're after hours now. Between what hours? We're after certain t values. And the good thing about this is they've given us a question with t values in it that we can manipulate. What are you going to do now to this to help you ask this question? Between what hours is he able to bring his boat back? What are you going to do with that? And what you've indicated you're highlighting here. This in red. This question here, the equation here. This question here. What are you going to do? What's the next step? Mathematically, h equals 6. Thank you, Jesse. And like we did before, if you've still got space, we now focus on this. Can you now work out your answer, please? Go as far as you can go. And I'll catch up with you. You can help each other if you want. Ask yourself, what am I trying to find out? What does my answer need to look like? Nathan? Yes, you do. I need. Can you answer it? If you've got t values, Nathan, keep going. But answer it in the context of this question here. Okay. We've got 3 sections. I need you to find out the t for those times. Okay.
This is just between like 6 plus in those sign. 1/2 pi out. Is that
Yeah. Keep getting to the t. Is that what you mean? Yeah. Show me your working out cells.
my working out?
Yeah.
Combined.
Nathan, so an exam you'll need to show working out.
Yeah.
So we're trying to get here. How do you get to there?
Take pi.
Take 5. Okay.
And then you divide by
And then divide by 2. Good.
so multiply by 6.
Okay, good. We're just backtracking here.
Right.
Whoops.
Right.
My bad. Okay, so we're up to this now. We've got a half. Let's say you didn't have a calculator. That's my clue. What are you going to do? You've seen half before. Where?
A triangle.
A triangle. Yeah. Which one?
The 60/30.
The 60/30? Okay.
10. Oh, 60 degrees.
60 degrees, good. But are we going to answer this in 60 degrees?
Right.
What's 60 degrees in? Is it pi on 3? Okay. And we keep going. So let's keep it at this first. Don't yeah, so with trigonometry, you need to be able to learn when to turn to the unit circle. Okay, it takes a bit of experience because naturally you might just keep going and you'll see why it's important to stop here. We've got a pi on 3. Remember, pi on 3 is 60. That's pi on 3. And this is CAST. But is our cosine a positive or a negative? It's a positive. So we're only interested in those two. Cosine is negative in here and negative in here because of the C and the A. What does A stand for again? Oh. Okay. Cosine. Pi on 3. So if that's pi on 3, what's this if I go around?
2 pi minus 5.
Which is? That's a 2 pi minus pi on 3. It's a 5 pi on 3. Got to be good at your fractions, guys. It's 5 pi on 3. Okay. So let's get back to here. We have this answer. I've just rewritten it the other way around. We have a 5 pi on 3. Let's go a few more just in case we catch more values within the domain. So it's important to keep going for a bit more. If I go around once and I go again to this second pi on 3, what's that? If this is 6 pi on 3, what's this? It's a 7 pi on 3. And if I go around again to 4 pi, but I come down again, 11 pi on 3 is correct. A lot of fraction work there. We can stop there. You can keep going a bit more if you want. So let's start backtracking. Let's change this to divided by 6, just to help our brains out a bit more. pi and t. If I've divided by 6 on the bottom and my timesing 6 on the top, what am I going to do with all of these? Get rid of a 3 and add a 2. And I'm just going to break it down. If you can do that in your head, you can. But if you want to do it full working out, it looks like this. And so on. Okay, and as was mentioned, these are all 2's because 6 divided by 3 is a 2. Okay, that should be 6. So that's now 2 pi, 10 pi. Is that 21? 22. Okay. Is that right? Oh, I meant 2 pi, 10 pi. Okay. What is it? 14? Should be 14. Yeah. Sorry, one blank. And the next one is 22 pi. Sorry. And if I have a pi in front and I've got pi's on there and I want to cancel them out, they just simply go. T equals 2, 10, 14, and 22. Okay, what does that mean? That means this. We found out successfully that that's 2. The next time it hits the 6, that's 10. Next time, 14. And it adds up on the graph, 22. Okay, our boundaries. So here, between what hours falls 0 and 2? What's our first boundary, first open window for him to, which is what's 0 again? 12 a.m. and 2 a.m. Good. What's the next window? 10 a.m. and 2 a.m. Good. And lastly, 10 p.m. and 12 a.m. Well, if we cut it off, it will repeat again. Okay. Now, last thing. Let's punch this on the calculator because you'll need some practice on the CAS. I'm just going to stop recording. Let's everyone get your